Hey, this is Andrew Brown, and welcome to the AWS Cloud Project Bootcamp, bringing you another video. And this time, I'm joined by Maish, who is a developer advocate at AWS, who's going to really help us a lot with containers in Fargate. I'm super excited to have him here because this is just deep, deep knowledge that I've always wanted, and we're going to share it with you. So I'm going to pass it over to Maish here to introduce himself before we jump into my big list of questions. So, yeah, if you could introduce
Okay.
yourself.
Awesome. Thank you very much, Andrew. My name is Maish Casing. I'm a developer advocate with the Container Services organization, products, and service team. We're a group of developer advocates which are embedded within the service team itself. That means we work very, very in tandem with our product managers and the organization, the engineers which actually write the code. And I was very, very happy that I was asked to participate in this week for the Cloud Bootcamp.
Great. So what I've done is I've written up a bunch of questions, and what I'd like to do is just go through them and see what kind of great knowledge we can unearth here. Because there's just a lot of things. I run containers, but I still don't know what I'm doing, and so it's great to have your expertise here to help us parse through that information. So what I'm going to do is pull up. I made a document. I'll pull up my screen here, and we can also look at code and the app if we need to. And we'll start there as a jumping point. So I will, I'll do that so we're not in the way. Well, I guess we can be on screen. It's not a big deal. As long as it's still readable. I'll bump up the font a little bit because it is a bit tricky. And so, when we were building out this application, Beko, who's also he's my co-founder, he's been helping with the bootcamp instructionals. We had a bunch of arguments about what would be allowed to run on a container for a web server. So we're using a Flask application, and it ships with a development server. Here it's called, well, Workzug. I don't know how to pronounce it, but it's a development server. And they caution you. They say, this is a development server. It has a built-in debugger. It's not intended for production use case. And so when I looked at this, I thought, well, maybe these are warnings of something that you would not want to use in production when you're using a virtual machine. And maybe this doesn't apply to containers, because when I started learning about containers, what I noticed was that the web applications were a lot simpler. They didn't seem to have these big, bulky, powerful web servers powering them. And so that's what I want to get to the bottom of. And so one of the first things that I know that a web server does is that it can handle multiple processes. It can be multi-threaded. And so then I have to ask the question, well, when you're using a container, how many processes are supposed to be running for an app? And in my head, I don't know why, but I read somewhere that it's one process per container. And so right away, you're losing the advantage of using those web apps that can, or those web servers that can process multiple processes. So what's the ratio? Is it 1-to-1 per process, or for one process per container? Sorry. Yep.
Exactly. So the recommendation is usually to have one specific process and a single process per container itself. The reason for that being is when we use containers, the idea is to scale up, to scale out on a massive scale. And if you need to start thinking about multiple processes in your actual container, you would have to take into consideration the scaling considerations of scaling different parts of your application or your web server itself. That is why the recommendation is only to one. A container is a process or a miniature operating system which runs one single process and does one single thing. There shouldn't be a database server within inside the same container, or a front end or a load balancer within inside the same container. These should be split into multiple containers as like microservices, because this really helps you with the container development methodology. It helps you to split your services into smaller parts, and you connect them between each of them in order for them to talk to each other in separate containers, but one process per container.
Okay, great. And just for our audience there, when I'm talking about these other kind of web servers, an example here might be G Unicorn. I know this server because I still am a Ruby developer, and we had a thing called unicorn, and then Python adapted it. They call theirs green unicorn. This is what I'm talking about. One of these servers that do more things like manage multiple processes, but we can see here that we don't need a web server to manage multiple processes because we're going to have one. Now, the next question to that is about threading. So, for example, the one we're using here, I mentioned it before, it's single threaded. And so then I go, okay, well, maybe we want to have a web server that can handle more threads. And so when I see these vCPUs, I think, well, what is the relationship between threading? Is it using, like, you have two vCPUs, you have access to more threads? Is it hyper threading? And then again, what's the ratio to it? So how does that map out? Or is it maybe there's no threads at all? I don't know.
So I wouldn't think of the fact of threading. I would consider your containers as the access to one CPU. Physical CPU. It depends on what kind of platform you're running on. You will get a CPU with this amount of compute power or whatever processor, if it's an i7 or whatever Intel processor or Graviton processor you're using. But don't think of the thing of threads. I would think about how many CPU cycles you're getting per your container. This is specifically relevant when we're using Fargate, because with Fargate, what happens in the background is you are presented with a full virtual machine or full instance, which is customized to the size of the task that you are provisioning. So if you, for example, chosen a Fargate task of half of each your CPU and 2 gigabytes of memory, you will get a specific virtual machine or instance, which is 2 gigabytes of memory and half a CPU. That's the only amount of CPU. You won't be able to consume more than that. So I wouldn't think from the hyper-threading perspective. Consider each processor as one single processor with that amount of cycles or megahertz or resources available to it.
Okay, great. So, that means that if I'm using this simple web server that's single threaded, it's going to be totally fine so far based on my checklist of being used for our use case, for production use case. That doesn't mean it is, because we're going to still figure that out as we walk through here. So another thing that they might say is that, these development servers or these simple servers, they might not meet the security requirements of what your application requires for production. And so when I think of these things, when I think of, web servers or web frameworks, they might have stuff like middleware where they filter out different requests or do things that make sure things are safer, like maybe like SQL injection. They might prevent that for an incoming request. I don't know what's built in this web server. I wasn't able to find out. But I guess the thought is, like, would that kind of stuff be abstracted out or taken care of by the cloud? So, like, let's say you have ALB or you have WAF there. Is there, like, is that security concern still there using these simple servers? Could there be something that, where we might want to use something that is more secure, if that makes any sense?
So when you're using the cloud, you have the option, I think, what we call the shared responsibility model, specifically in AWS, where part of the application or part of the stack belongs under the person who is creating or running the software, and the other part belongs from the infrastructure where we handle that responsibility belongs on AWS. It depends, of course, where in the spectrum you're running. For example, Fargate, we say that we manage all the EC2 underneath and all the virtual machine which is running. All you need to do is provide your application, your definition. We'll handle all the security, the patching, the rebooting, the upgrades of all the things running underneath your operating system. You're responsible from the container and upwards and everything above that. If you're using EC2, then you're responsible for the container and the operating systems and patching all those things as well. So it will vary on the spectrum. Regarding the production environments and debugging, the way I think this, and I think most people in the security realm will say, you need to have your layers of security. So I would prefer to have my application as secure as possible, and with the least amount of vulnerabilities or options for perhaps disclosing information. That is why, for example, in the application you're using in the background, you're saying don't run a debug on a production environment because it can expose information, just extensive logging. You'll probably use more resources than it's supposed to do. Yes, you can apply different services above and beyond the layer of the container or the application load balancer, which will protect you by using, for example, CloudFront, which is a CDN, or you have a web application firewall, AWS WAF, which can even close off, for example, where your application is allowed to be accessed from different countries, different clients, whatever, those kind of things. You can add extra security, but still, I would still keep the security of the actual container as tight as possible and only expose what is really necessary, because in the end, it is the application which is running your code and exposing the application out to the outside world.
Okay, so as a customer, there is a level of responsibility that's my own. Obviously, I get to choose what web server I want to use, and so I'll have to investigate that and make the trade-offs. So right now, at this
Correct.
point, I'm not 100% sure what security features that this web server has. I'll have to compare that with Gunicorn and then think about what is being offloaded, what is being responsible for the provider. So that sounds great there. What I noticed is that when I'm going through AWS documentation, and is that it almost validates my thought that I don't need a more complex web server, and I just don't know sometimes in the documentation if they're doing it because they're doing it the easy way. They're saying like, here's how you do it, but you wouldn't necessarily do that production, or if that's actually the way you do it with containers. So when I saw, and maybe this is for Ruby, not necessarily for Flask, but they would use WebBrick, which is the built-in one in the standard Ruby language, and people would want to go jump to Unicorn and use that. Do you think maybe that might be because of these other reasons we listed here? Because that web server doesn't need to be multi-threaded, doesn't need to manage multiple processes, so it meets that use case. Like, how should we treat the documentation when we see it? Sorry.
So the documentation provides same defaults for all of our customers. We do provide examples of more complex projects which you can build up, usually either on the documentation itself, or we have examples available within either AWS blog posts or GitHub examples, which are available also online through our AWS samples GitHub repository organization. You can look for those as well. The fact of the scaling and security and monitoring and logging, most of the things are built into the container orchestrator itself, specifically in ECS. You just have to provide the logging configuration where you would like to log, and automatically it will log to you for CloudWatch. You don't have to implement that in your actual web server itself. As long as the log is exported to std out, it will be logged automatically into CloudWatch for you. The same thing about scaling. There's no reason to manage the scaling in the application or spawning more processes of the web server, because, as we say, we prefer one process per one container, and the orchestrator in the back end will manage the scaling for you. If you need to scale up higher based on the metrics, your CPU usage, your response times, those things can be done for you as part of the orchestrator. So maybe we are taking a good part of what we call the undifferentiated heavy lifting in the background in AWS, and moving it to the services which are providing that for you, instead of you having to implement it inside your application logic itself.
Okay, great. So one thing I was going through was that I really wanted to use a service mesh, because in my head, I know they have some great advantages. I might be wrong, but we'll get to that. But on a side note, I noticed that I had to use AWS VPC networking mode to use it. But when I was using Fargate, I noticed that it wasn't in the free tier. Now there is some spend, and it was a negligible spend for learning, but I wanted to see if I could try to get a zero spend using ECS EC2. So I went down that route, and what I found was that I discovered another limitation I wasn't aware of, which was when you launch up the cluster. It's let's say on a T2 micro or T3 micro, you can only have 2 ENIs. So when I launched my first service, there was 1 ENI for the cluster, a second one for the backend, and then when I went to launch the third one, I found out, well, I didn't have enough ENIs. I'd have to spin up another T3 micro, which was possible, but then I thought, I'm making this a little bit too complex for students, and I would go back and just use Fargate, and there would be some spend, negligible spend, but one student was asking me, said, Andrew, why can't we just use bridge mode? And my answer was, well, I want to use service meshes. And then I thought, well, what would be the use case other than reducing costs for students when learning? What would be a use case for bridge mode for a production use case?
So for a production use case, firstly, so let's just make clear, for example, on Fargate, you can only use AWS VPC mode. There's no other mode besides that. On EC2, you can use host mode, bridge mode, and AWS VPC mode. So 3 different modes you can choose for your EC2 instances. Host mode will expose one port to one, we'll take the same port located on the physical host and expose it to one container one-to-one. So you cannot have 2 applications running as in a container on port 80 on the same EC2 host. If you do want to do that and run multiple instantiations of a container running on the same internal port, you would use bridge networking mode and use something like an AWS load balancer or an application load balancer, which is tied in through the service, which will automatically map the external port to an internal port based on the Docker networking inside the EC2 host. So you can have multiple internal ports running on 80 on a container. They will expose external ports on different port numbers on the host, and the load balancer will be able to map automatically into each and every one of those ports. That would be the use case for running multiple containers on the same port on the EC2 instance. AWS VPC mode is completely different. It uses an external network interface from AWS, an ENI, which is a network on the VPC, which comes with a lot of, I would say, benefits, mostly security benefits. For example, you can manage security groups per container, per ENI, which is not really exactly available if you start using bridge mode, because it's only one ENI which will be exposed to the outside world, and everything on that ENI will have to have the same security rules regarded, which will funnel back all the way into all the containers on the host itself.
Okay, yeah, and so that, I think that was the big thing, which was I did not realize, or I mean, thinking about that makes sense because for bridge mode, why they would not all have individual security groups, but I could see a huge a benefit for security for that. Getting into like the service mesh zone in AWS, and I'll try to see if I can best organize these questions. But one thing I noticed is I was using Fargate 6-9 months ago, and at that time, at least at the time when I can't remember how long ago it was last summer, I think, maybe farther, actually more a year ago. But at the time, I don't believe Service Connect existed, or at least I never used it. And I was using AppMesh and Cloud Map. And so when I went and implemented those, I got it working, which was great. But then Service Connect came along. And so to me, it looks similar to those, but it looks like it takes away a lot of that work. Is it basically a simplification of those two services with different trade-offs, or is it the same thing? Like, would I get the same result if I was to do both?
So
like either or.
Service Connect was released at reInvent last year in November 2022 at when we had reInvent Las Vegas. It is kind of an evolution of AppMesh. It does use Cloud Map as part of the resources underneath, but from what we heard from our customers was the fact that managing AppMesh at scale was very, very difficult because they had to manage a number of Envoy containers in the background and manage the whole deployment, which was not so simple. What Service Connect does provides a more simple experience for our customers as a managed Envoy service, where they don't have to worry about deploying and configuring anything with the actual mesh inside. It's a seamless service which is integrated with ECS. And above and beyond, it provides a number of improvements that, for example, for AppMesh, it was mostly related on the fact of load balancing. Not the load balancing, the scale up and scale down was done by adding resources into DNS. So adding extra A records into your DNS that would load balance in between the DNS. With Service Mesh, is actually done without DNS at all. Everything is done in one place. And the load balancing, the scale up and scale down is done with the Envoy itself. So it provides added benefit to the customers, makes it a lot simple, much easier for them to run some kind of a service mesh inside their environment. It does rely on Cloud Map in the background as part of the service as well, as part of the service which it provides. But it's, I would say, the evolution of what we have for AppMesh.
Okay, and I think that answers one of my another question, because I noticed when I was setting up Service Connect and we were adding it to whatever the configuration was. I saw a DNS option, and I went, well, I don't remember app mesh requiring any DNS option. And so you're just saying there that there was a difference there in that use. One other thing that I noticed, or I was able to do, which I really liked, was that when I was setting up app mesh last year or whenever it was, I ran into a scenario where I had to use NLB, like network load balancer. I think I could use ALB, but then I ran into, I can't remember, but I ended up having to settle on NLB. And it was more so that at the app mesh, you had to do your routing there. And there was some limitations on the routing. So when I use Service Connect, I was able to use ALB. I was able to use the full range of rules that I'm accustomed to. And I was like, oh, I really like this. And I was actually surprised that I didn't have to use NLB. So I'm not sure, is that an improvement of or an evolution of the other one, or it's just an
I would say
way?
An improvement, an evolution, and simplification makes things a lot easier for customers to do what they're used to doing up until now, and removes limitations of what they had from before.
So it might not be obvious to some folks if they're not familiar with Envoy or service meshes, but every time you launch up, or if you use Service Connect, it's going to launch an additional container, an Envoy proxy.
Correct.
And so I guess the question there is there any kind of overhead? Like, how much does it consume alongside your container? Like, or what do you have to budget for when you run Envoy containers?
So I'm actually looking at the documentation in the background. We say what the recommendation is adding approximately 256 CPU units and at least 64 megabytes of memory to your task CPU for the Service Connect proxy container. Okay. On Fargate, you have to add minimum of 512 megabytes of memory for that instead of the 64 megabytes. So there is a certain amount of overhead which you have to add to the size of your task. So instead of using what you were used to, for example, 1,024 CPU units for your task, you now get 1,024 plus another 256 when you use. There is a bit of overhead, but the benefit that you gain from it it goes way above and beyond the actual, I think, the price that you pay for, or the price that you pay for using these actual containers as well in the background.
And so this is the next question, where we talk about when does it make sense to use a service mesh. So our application, very simple application, has a front end and a back end. They technically don't really need to do service-to-service communication internally, because they're just going over the internet and talking to each other over an API. At what point does it make sense to, or would you see the benefits of using a service mesh?
I think the benefits come when you have a really not complex, but expanded, or I would say evolved architecture, which has hundreds of microservices that need to talk to each other, one between the other, and you not necessarily know, for example, what the IP address is of that API, and it might change over time. So when you're using a very big architecture, which has to understand different components, which are talking to multiple components in between each other, then a service mesh makes a lot of sense to use those kind of things. And of course, when you would like to get more insight into your application and the traffic going through, you can also use, for example, Envoy, which will provide you a lot of statistics on the kinds of requests, how long they took, and all the metrics in the background as well, which will give you above and beyond just adding the actual name resolution between them.
Okay. I've heard of Container Insights. I've yet to use it. I don't know why. Sometimes you're just like, there's this thing, it might be really easy to use. At what stage does it make sense to start using Container Insights? When you're starting out really early, like we are in our application, does it make sense to turn it on now? When should we take advantage of Container Insights?
I think if you are looking to gain proper insight into your applications, understand what it's doing and what the application, specifically if you're talking between multiple applications or multiple AWS services, Container Insights will provide you a huge benefit straight from the get-go. So for example, if you're talking from a container which is talking to a DynamoDB, a database, or a S3 bucket, or those kind of things in the background, Container Insights will provide actual proper insight, how long those requests took from the container to the DynamoDB, where you'll be able to start finding the hotspots or the heat map within inside your application where things are slowing down or taking too long. It's very easy to use. You just do a checkbox and turn it on. That's all you need to do. It automatically comes on and will provide this insight.
In terms of cost, is it what, like at our scale, is it expensive? Do you think we'll see some pennies or?
A few pennies, because it's CloudWatch logs. All you're doing is you're
Uh,
writing a couple more logs into the CloudWatch, and that's it. Nothing else besides
um,
above and beyond that.
is Container Insights requires X-ray? So do you need to instrument your containers or your services to have X-ray alongside
I
it to get the
think
data?
that I cannot remember. I think you do, but I won't say for sure because I don't want to give a definitive answer of things
Okay.
I'm not 100% sure. But I think you do. I'm not 100% sure.
Okay. And I will find out, because now that you said, you've taken the fear out of me. I think I'll go and attempt Container Insights. Um, and I think one thing we actually did struggle with a bit was X-ray, but we were instrumenting it manually. And at the time we were looking at ECS EC2, where I believe you have to run your own daemon within the cluster. But I think I recall it being a lot easier with Fargate. I'm not sure
Correct.
why. Yeah.
It should be because I think it's automatically instrumented throughout with the virtual machine, which comes with your containers inside. So you don't have to worry about those parts at all.
Yeah, so maybe we'll give an X-ray a better look at this time, now that we're back on the Fargate route, which we should have just stuck to begin with there. Um, I think we're coming near the end here. I just have a question about Copilot. So for those
Okay.
who don't know, Copilot
Okay.
is what's the nice? I'm trying to think of what it is. It's a tool that makes it very easy to deploy and provision containers. And so
Correct.
I have some practice with it. And my thought was that it was really easy to use, but it would have taken out a lot of the learning experience for us underneath, because it abstracted away a lot of that stuff. But
Exactly.
from a long-term perspective, is that tool intended to be, you use it as a learning experience, or is it to get you started with good sane defaults, and then you can take that architecture or those templates and then maintain them long term, and maybe you discard Copilot when you outgrow it? Or what's the technical path when using Copilot?
So Copilot, as you said, is a CLI which allows you to deploy containers either to Fargate ECS on EC2 or also to AppRunner, which is another product which we have as well to deploy containers on AWS. Same CLI, the same experience, same kind of configuration, pretty much the same of everything. Of course, the thing is, as we say, it's an opinionated way of deploying different containers or different, I would say, stacks or types of applications. If it's a front load web load balanced application which will be exposed to the internet, there's another one for a pub sub, for example, for things which are based on queues. So another one is a backend application which doesn't have any front end applications exposed to the internet. The third one, I think, if I remember, the fourth one is the fact is an app runner application, which allows you to deploy to a completely different service. But it's an opinionated way of, okay, you take this container, we'll provision all the underlying resources for you, the load balancer, the service mesh, the VPC, the subnets, the configuration for your Elastic Container Registry for your images. We'll do all those things for you underneath, but you need to provide the code and some configuration about how you would like your application to run, how it will scale, how much memory, and number of different things you can provide to the environment. It is an amazing learning tool, but it is also a tool which you can use as well as in production use as well. Specifically above and beyond that, which we released, I think, either yesterday or 2 days ago, the latest version of Copilot 127, which allows you to do, I would say, above and beyond what you were able to do today, and provide overrides, which are things which are not available by default. In those opinionated defaults, you can provide either an override through CDK or an override through a YAML file, which is provided as part of the CloudFormation deployment. You can do things above and beyond which was not available today within Copilot. And as a result, it will make it even more of a production usable tool. Not that it wasn't
Okay,
up
yeah.
until now. A lot of our customers are using it up until now, but it gives you even more possibilities and flexibility in your applications and deployments.
Okay, yeah, and I think that's where, when I looked at it, I went, well, where are those overrides for down the road? And so I'm hearing that those are getting addressed, and so now we are able
Exactly.
to take it to a production use case. My co-founder Bako loves Copilot. I think that it does I know, like, there's what we call Docker context, where you can deploy a Docker Compose file directly to Fargate, and I think that it uses Copilot in some way. There was some reworkings there where it used to use AWS CLI 1 and then it had AWS CLI version 2. I don't know why I keep thinking it uses Copilot, but I'm just finding that it's getting easier to deploy containers is my a line of thought there. I do have a couple more questions if
Okay.
time's permitting here,
Yeah,
just
I'm
because we
good.
got great knowledge here. So one thing I know is that you know everybody wants to be on Kubernetes. Whether they should be on it is another story. But maybe down the road they want to get there, right? And so even us, we're
Yeah.
like we were just thinking like, yeah, let's get to Kubernetes. And but you know what, Kubernetes, I made a course on it. Doesn't mean I can do it in production. But um, uh, you know, we thought, okay, let's take a stepping stone to Kubernetes because we know that Fargate can run on Kubernetes. You know, what's your
Right.
thought in terms of it as future technical pathing to say like, look, we might want to open that path open to us in the future and make the migration there as easy as possible. Do you think using Fargate as a stepping stone could lead to Kubernetes, and so you can just bring that over at some point, or are they too divergent in terms of technology?
So I do want to make one slight comment about what you said. It's not Fargate on Kubernetes. It's the other way around. It's Kubernetes on Fargate and ECS on Fargate,
Oh, sorry.
because we consider Fargate as a compute engine. It's where you run your container. What is the computer underneath which is running your container? It can be an EC2 instance, which will allow you to do certain things or prevent you from doing certain things. But Fargate is a managed serverless compute engine which can run containers either from ECS or from Kubernetes. If you understand the mental model of what Fargate gives you, which is lower operational cost, lower operational overhead, lower operational toil, lower patching overhead, more security. In this case, you don't have to worry about all those things on your own because it's part of the service which is provided underneath. The change between ECS and Kubernetes is not going to be reliant. It will be easier for you to understand when you want to run Kubernetes on Fargate if you've already done it in the background and understand what the mental model of what using Fargate gives you the benefits. It won't make running Kubernetes easier. It won't make running ECS harder, but it will give you at least that mental model of knowing I have a container, or in this case, in ECS, it will be a task which I've defined of the container and the resource I provided to it. And if I do that same thing on Kubernetes, it'll be the pod or the pod spec which I've defined, and it will provision that compute instance underneath based on that specific specification which I gave to my pod or my pod spec, and will provision a computer which is only running that specific application itself without having to worry about patching that underlying instance in the background. It will all be done for you in the background with Fargate. So I don't know if it makes it a technical stepping stone. It's, for example, if you know how to drive a car, the car will do the same thing. It doesn't make a difference if you're driving a Mercedes or if you're driving a Dodge Caravan in the background. It doesn't really make a difference. The same underlying basics are there. It will be easier to go between one to the other if you understand how a car works, what the steering wheel does, what the wheels are for, what the brakes are for. And that, I would say, the analogy underneath is that's what Fargate is from the compute engine. It gives you the option to run a container. Where you interface into that compute engine depends on your preferences, if it'll be ECS or EKS. I have my own preferences, of course, ECS, not EKS, but that's a different story.
Well, and the interesting thing, you know, for us is that you know, learning how to build a distributed application with multiple containers. Kubernetes it seems really cool. It has a lot of moving parts. ECS seems to have less moving parts, and it's making it easier for us to get that mental model and figure it out. That's my personal opinion. But yeah, I thought we could jump right into Kubernetes. Nope. But you know, maybe we'll just live on ECS and we'll be happy there. Time will tell.
Yeah.
Oh, sorry. So what I'm really excited about, it's in preview, and I just haven't seen if I can get access to it. But uh, VPC Lattice. So I don't know if this is going to be revolutionary or not, but to me, it looks like something that could be a competitor to, or not competitor, but an alternative to Service Connect, and be able to go outside the scope of just your cluster. Where does VPC Lattice in the future fit in terms of our architectures?
So I think it will be the VPC lattice will be, of course, integrated, or there will be integration definitely between Service Connect and VPC lattice in the future.
Mm-hmm.
Where currently Service Connect is for ECS in cluster, sorry, not in cluster, in your account only, because you can use the same Service Connect between different clusters, between different VPCs in your same account. It's the integration over there is for ECS itself. VPC lattice will provide the same kind of, I would say, I wouldn't say the same functionality, similar functionality of a service mesh or service discovery for workloads which are not ECS. So if we were talking about Lambda, or maybe in the future, Lambda maybe, or EC2 or whatever else it may be, this will provide the connection between, and you'll be able, of course, there will be an integration between the two of them, where things will be able to talk from EC2 from ECS into VPC lattice, and VPC lattice into ECS. There will be a bridge, of course, in order to make some kind of cohesive story between these two different services to provide a full, easy solution for all of our customers in the AWS cloud.
Okay, so Service Connect is not going anywhere, but we're hearing a bridge to other services. But
Correct.
I mean, to me, that's super exciting. Last question, I promise. It's just around Envoy. So, and specifically, like, what happens when whether you even need Envoy, like to be able to configure it. So, like, Envoy is very powerful. You can do quite a bit of configuration to it. I don't know if a lot of people know how to. Even myself, I go, there's a lot there. And so, from a technical path, I go, what am I losing from not being able to directly configure Envoy? Can I give overrides into Envoy on Service Connect, or I have what I got, and that's good enough? But what do customers do if they outgrow like Service Connect, or they think that they want something more complex with like the configuration to Envoy? What do you do then?
Okay. So as part of any managed service, I think that by using a managed service, you give up some kind of freedom. If it be on Fargate, you're not allowed to do everything. If you use ECS or EC2, you also can't do everything. You only get a certain level of control of what you want to do. The same thing will be with Service Connect. We are exposing a managed service for Service Mesh and Envoy. And as a result, there will be things you are allowed to do and things you can't configure or do with overrides. Even as I said that, of course, we are interested in hearing feedback from our customers. If there are things which we are not providing inside the managed experience of Service Connect, to hear back from our customers, and that you can do through our public cloud, our public roadmap on the containers roadmap on GitHub, to hear that feedback, to hear what other things you're looking for which are not currently provided. Public AWS containers roadmap, you should be able to find it. Exactly, the first link, exactly. So there's open up an issue, look for current issues which are already there to see if there are any requests for the same request that you're currently looking for. This shows our public roadmap of what we're looking at for the near future, the further future, or the far further away back future, what we're looking into. So you can have a look and see if there's anything specifically regarding Service Connect. And specifically, if you want to, reach out to me, because this is part of my what I do is I listen to feedback from our customers and from anybody who's using our services. My Twitter handle here is on the screen. You can send me a DM, reach out to me directly, provide that feedback. I'd be more than happy to listen to a conversation and understand exactly what you're trying to do, what is not provided in the service, and pass that feedback onto the service team so we can see if we can get it incorporated into the product itself.
And I think the great thing about having public roadmaps is that if you're concerned about the technical roadmap in the future, you can better align to where it might possibly go by seeing what those features that are to say, oh, AWS is thinking about the same things that I'm thinking about. So if and when I might need those down the road, they may be there, and so I should stick around on the service because it might satisfy that requirement, so we don't have to go start everything from the ground up again.
Correct.
So I think that answers all my questions, and I know it was a lot, but there's a lot of things that I think are worth trying to dig up for folks here, especially when they're learning how to use containers for the first time. And so I greatly appreciate you bringing all that knowledge forward for us. Do you have any parting words for our boot campers?
Firstly, I applaud you all for doing this and embarking on this journey, because it's not easy to do, specifically for this a long period of time. So my applause to you goes out to all of you. Very, very well done for going through this process. It is, and above and beyond that, my applause to you, Andrew, for bringing this whole thing to fruition. You and everybody else who's working on this product is amazing. The contribution to the communities. Thank you very, very much. It helps people grow, learn more, become more knowledgeable in the containers and everything else regarding AWS itself. So really, really thank you for organizing this and doing this for all the community.
Great. I appreciate you coming here and sharing your knowledge today. So yeah, boot campers, I'll see you in the next video as we carry on, and we'll see you soon. Ciao.